Hello and welcome to SDN Tech Forum. Welcome to Unix Linux Masterclass. Previously, you have seen on day one, we installed a Ubuntu and a Red Hat Linux server. And then on day two, we started talking about directory structure, basic navigation, and the package manager, apt-get, apt-upgrade, apt-get install, and similar thing for RPM, Red Hat Linux using Yum, right? So now you know there are two different type of package manager and how to use them. We we have started with basic navigation, but we didn't finish. So on day three, we'll continue with basic navigations. We'll understand about file permissions, and then we'll look into environmental variable and try to decode how the path is being used in Unix Linux system. Then we will understand the processes by using top or htop and try to decode them. All right, so that's the agenda for day three. This is our Ubuntu system. As you can see, we are running 20.4.6 LTS, right? And again, if I'm not looking at camera and I'm looking down, that's where I'm looking at my notes. So because I have a lot of notes open here. All right, let me move. So CD, change directory, we'll go to desktop, and within desktop, again, you can do ls listing. We have done that before. And as you can see, we have another directory with permissions, and we'll talk about the permissions in a moment. All right. So this is the directory. Again, you can see where you are using pwd. So this is the current or present working directory, and you can navigate using shell. You can go one level up, cd dot dot, that means take me to the parent directory, or you can go two level ups. So you can very well mix this, and now see where you are. You are two level up. We were at lesson data, and with one dot dot we move to desktop, and with another parent directory we move to sdn2. All right, to go back to your home directory, you can use a shortcut tilde, and that will take you to your home directory. Now I can define the absolute path, like complete path. So I know desktop, lesson data. In one shot, I'll be moving to the target directory. Also, one last hack with CD is CD dash. If you do CD dash, it is actually switching you back and forth between your current directory to previous directory. If I'll do again CD dash, I should go back to cell lesson data. As you can see, that's where I am. All right, so this is all about CD. And now let's see what kind of data structure we have here. So with LF, as you can see, we have exercise data. Let's go to exercise data, and again do ls hyphen LF. So here we have some numbers, right, and some other directory. As you can see, this is denoted. So this is directory, D for directory. This is the type, right? All those things, and this is a text file, ASCII text file. So if you want to open or read a text file, what you can do cat. As you can see, this is listing whatever we have in the text file. It's kind of like opening the text file. There is an interesting variation of cat that you can do tac and then number.txt. See what has changed. So with cat, you read from top to bottom, but with tac, as you may have guessed, you read in the reverse order from bottom to the top. That's how it is. You can see here that 6 was at the bottom, but now with tac, the bottom comes to the top, and that's how it is printed. Cat is very handy in the sense there are certain flags which you would like to use. So first let me just quickly do cat help. Though this is not very flag rich, some of the commands they have uh, 20, 30, 50 type of flags. Cat doesn't have that many, but still few flags are really powerful. And the one what I really like is -n. So here we will do the same thing. Cat -n number dot text. Here what you can see, I have the number printed for the line. So I know how many lines I have in this file. So there are 5 lines. There is another option um, which is e cat hyphen e number dot txt, and this is telling me that what is, if there is any new line or something, it comes handy while you are editing the file, so it show you the end. So luckily we don't have any new line argument here. Every line is ending with that variation. So this is cat. I have already shown you touch, so you can use touch to create an empty file. Delete me.txt, and if I do ls-l again, you'll see there is a delete me.txt file got created, and it has 0 size. That means it's empty. If I try to do cat touch, oh sorry, cat delete me.txt, there is nothing. So why we would like to create an empty file? I think in day 2 I mentioned some program, say TFTP, etc. is when you want to move a file to that location, it is expecting that there is a placeholder file is already present. So that's where you would like to create an empty file. All right, now what we are going to do, we are going to delete this. So delete that, what you can use RM, that means remove, and you can do couple of flags. One is very interesting, R, where we use it with folders or directories. So if you have a directory which has a child in it, you can say remove recursively. That mean remove everything underneath. So you can do that, but you should be aware that RM is in Unix Linux is kind of permanent. As you know, in Windows system, whenever you delete something, it goes to trash. It should sit there for some time, some duration, and then eventually get deleted. But in Unix, that's not the case. Whatever you delete, it's permanent. It's gone. So right now, as you can see, rm-r delete me is deleted. All right. What I can do, I can also use rm-i and number.txt. So this is interactive. It is asking me or probing me that do you really want to delete this? And accidentally, if you typed RM and a wrong file name, this is your opportunity to back off. And that's what we are going to do. We don't want to remove this, so we're going to do a control C. That means about this operation. And as you can see, our number.txt is very well intact. All right, so that's cd cat and uh, rm. Let's talk about two important stuff, which is copying files and directory. So for that, let's look at cp. Here I'm going to say cp, which is copy file number.txt, and then what I can do, I can specify the new file name or new location where I want to copy it, right? So let me copy it to desktop, and so I'm going to say I can copy it the same location like old number.txt, but that's not the purpose, right? You would not like to copy the same location. You may want to copy it to some other location. Most of the time that's the requirement. So let me get rid of old number.txt, and we will copy this number.txt to our um, desktop. And for that, I need an absolute path for that directory. And if you remember, when we started, we were doing a couple of PWD, and within PWD, I'm going to find my home directory. Right. So here you can see copy number.txt to my home directory. And as you can see, this is copied, but there is no confirmation. Unix is kind of uh, unique in the sense that it doesn't tell you whether the command has done something or it is accepted. So most of the time, if you don't see a error, think your operation is a success. Whatever you try to perform, that operation is successful. So let's go to our home directory, cd tilde, that's a shortcut. And I'm going to say ls-l again. And here I'm looking to see number.txt. Right, so the copy did work and my file is available here. All right, so we do cd dash, and let's go back to the same hierarchy. We are back to exercise data. What else you can do here? uh, let's create another file. And there is a, so I showed you two ways to create a file: touch and uh, uh, yeah, uh, touch and cat can also create a file. Like if I do cat new file .txt, and then it is sitting, it is asking you to enter the content of the file. This is very long file. Oops, sorry about that. So this is very long file. All right, so we would like to get out of this, and for that, what we can do. All right, I think I don't remember. We'll come back to this. Right, so new file.txt is already created, though we didn't came out of it gracefully. As you can see, if I do new file.txt, I have all sort of things, right? So maybe the commands control C did work, but it was not very graceful, right? We'll come back to that. So our new file is created using cat. What else you can do? You can use editors like nano, vi, vim, and we will talk about those editors in the later videos. But let me quickly show you one more way or simple way to create a file. File one, and this is our very simple editor, simplistic editor. This is file created in editor. Some text. What you can do, you can use Control Shift O, and it will ask you file name to write new file. That's correct. And now if once you are done, you can exit out of it. Control Shift X to exit. And if I do ls-l, you can see I have new file, though there is no extension, right? You may be wondering, is it like a file? Is it a text file, or what kind of file it is? So let me see. Here you can see this is pretty much a ASCII file. And now what we will do, similar to copy, we'll try to move this, right? So when you remember when I created the file new file.txt and I copied it to my home directory, So now I have this file available in two locations. One is in new file.txt, which is sitting here under exercise data, and another one is, oh, did we, I think we deleted that, but make copies, so we'll have the two copy of that. And quickly to prove that, let me do it one more time. So we will go back to our location, and with up arrow I'm going to bring the old commands. All right, so let me find cp number.txt, which is still there, it is available, and we go back. We're going to check number.txt is here. We will go back to our exercise data. Let's -l number.txt is available here as well. So you can see CP made a two copy of this. What we can do, if that is not optimal, right? You really want to have just one file, but say you are rearranging thing and you want all your exercise data file in one section, you want some departmental file in another folder. So what you can do, you can use move in that case, and very intuitively it is mv for move. Here what we can do, we can say new file one, move this new file one to uh, to my home directory, and yep, let's do that. And we have moved new file one. Let's check what happened on the at the current directory. You can see we do not have new file one here anymore. There is no new file one at the current working directory. What we can do, we can go back to our home directory and check. Here you can see we have the new file one moved here, right? So this is CP on MV, but there are some flags as well, which goes very well with them. So what you can do, you can do MV help, and as you can see, you have MVI just like RM. Before move, you want to prompt an interactive move, that's I, and then we have F, T, target directory. You can specify a target directory location, etc. Pretty simple, but very useful. You'll be doing this pretty much all the time. All right, so you can also use wildcard matching. You don't have to say um, specify the if all the name. You can use globbing, and I'm going to show you that in a moment. But yes, uh, let's create a couple of folders. So we go back to our home directory. Let's open IL, and here you can see this is a typical directories, right? So or typical file structure for any user. If you want to create a new directories, you can do mkdir, and we'll say create a gntech, enter, let's -lf. You'll see we have a new empty directory created, which is sdntech here, right? You can also create multiple directories at the same time by just uh, using a slash. So let me get rid of our directory sdntech, and here you see sdntech is a directory, so we cannot remove, though it is a empty. There is not nothing any underneath this. What you need recursion for this, and now it's gone. So you can do mkdir sdn1 sdn2 sdn3, cannot create any directory. All right, so we need a flag. What flag is this? We need a parent flag. What happened? As you can see, we have SDN1. Let's go to SDN1. We have SDN2. Let's go to SDN2. We have SDN3. From SDN1, SDN2. Okay, mkdir. We created two SDN. That's why it should have created SDN3. But you got the idea. Under SDN2, there is another SDN2, as you can see, right? So let me go back to level up, and I'm back at my home location. Let's go ahead and delete the directory, and it's going to delete the parent and all the child underneath that, or subdirectories underneath that. ls-l f and no SDN. Now I'm going to show you one very quick and easy flag, which is grep ls-lf. We are doing this listing all the time, but it lists so many things, right? We don't want to see all of these. I know what I'm interested to see, so what I can do, I can say grep SDN. Oh, that was a bad choice because it matches all the line. Our username is SDN. So that's not a very good choice. Let's try something else. Win. So we have one winserver.pcapng. That's the one file, and it is meeting the grep uh, format. Hence return that one only. All right. Let me show you another command called word count, and this is very interesting. When you're working with a file and you have multiple columns, what you can do, you can do WC, that is word count. And what it is doing, it is actually going ahead and counting everything, how many lines you have, how many words you have, and how many characters you have in those columns. All right, let's go to where we have our lesson data, exercise, and then, all right. So for numbering here, I'm going to show you something like cat number.txt. We have already seen the context or content of this file, but this is like haphazard, right? We have some numbers and maybe we want to sort them. So what you can do, you can use sort, not snort, sort hyphen in. And now as you can see, they are very well sorted in ascending order 2, 6, 10, 19. And just what I have done here is I have used a command which we haven't talked about yet, but I use that, right? You know, I used short and then the flag, but what I have used as along with is this pipe command. So what is happening with the pipe? Pipe is operator which actually take the output from the left side and use that output to feed in as an input to the right side of the command. So you take the output from the left, use that output or convert that output uh, as input to your right side of the command. So cat number.txt was printing something like this, and it take all these numbers and try to sort them in ascending order. So pipe is a kind of it's misnomer to say join operator, but it stitches two you can use multiple pipe in one line as well. So it's not like that it's restricted to just one pipe. You can use output of this and feed into this, and then you have another pipe, and you keep on doing that. So pipe is very powerful. Yes, you will pretty much use all the time. All right. Now I'm going to show you another operator, which is append or redirect. So our first redirect is echo dollar. I'm going to say we have seen echo, right? So whatever you echo, it just return it back. So if I say echo hello world, you can see hello world is printed. Just uh, echo it or spit it out of the standard out. But what else you can do? You can say echo hello world, and by default echo goes to standard out, std out, and I'll come to that in a moment. But what I want to do, instead of sending it to standard out, which is our console, I want to redirect it to a file, and I'm going to say hello.txt. So this time you see there is no display, but the output has gone to hello.txt. If I can show you that, hello.txt, hello world, right? So that's what happened. So using echo also you can create command, create a file. So what if I do another echo I am new here, and then I send it to hello.txt. Let me see our content again. I am new here. But what happened to hello world? There's no hello world anymore, because single redirect, as you can see, this is the redirect. Single redirect always does a overwrite. So whatever was there before, it will get overwritten by the new content. So we used to have hello world, but when we said I'm new here, this one got overwritten, which is not very good, right? If you want to continue working on a document, you are putting new comments and etc. You don't want it to get override. So what else you can do? You can use a operator called append operator. And what is that? Let's do another echo. What about you? And this time you'll see we will do an append operator, and that is to redirect to the same file. And let's look at the content. This time using it preserves the old content and append a new content. So I am new here was there. What about you got appended to the file. So this is about operators. This is called append operator. All right. Now let me show you uh, something called head and tail. Okay. So we'll work with our number file again. Head hyphen n to number.txt. As you can see, we had 5 entries. If I do cat n number.txt, we had 5 entry, But if I want to print only 2 from the top, I can use head. So only 2 entries were printed. Contrast to that, what you can do, you have tail as well. So same argument, but we want last 2 entries. And if I do so, you can see tail last 2 entries are printed, which is 6 and 22. You can mix head and tail together, so you can be really creative in Unix, and the pipe operator is your friend. Right? All right, so basic navigation, these are really cool things, and you should be using it every day. Now let's go back to our next topic, which is understanding the path. But this is whatever I have shown you is very limited. You will be discovering more and more as you continue working through it. Okay. So now what I want to show you is we'll switch gear. So I'm going to clear thing and cd to my main directory. Now we won't be working with the directories anymore. We'll working with the system. Okay. For system, I want to show you first is environment variable. I have already shown you the shell part, echo $0. I should print what is your shell look like. Like bash is a default shell. For Ubuntu, if you are in Mac OS or something, you may have a different shell. I think G shell is default for Mac. So we are talking environment, and for that I'm going to say env, which is environment, cat n. So that type of fat finger there. En. So it is printing my environment, and I intentionally printed it with cat -n so that we know how many lines we have in our environment. Okay. So I'm going to explain you this environment variable one by one, or the main feature of this environment variable. First, you should see shell. So you know the shell is the interactive program which help you work with your operating system. So our shell is bin bash. This is the default. Then present working directory or home directory is this. Log name, your log name is sgn2, and how I'm logged in for this session, I'm SSH to the machine, hence I see TTY line. All right, this is my home location, language is English, US, UTF, and some color, etc. Right. SSH connection, right now it is showing me that I have made a SSH connection to this machine. Source and target IP addresses are listed here. Term is by default, this is the terminal, so it's defined the value. This is I'm using xterm with 256 color, and user is sdn2. But the most important, probably the most important thing what you want to know in this environment, in this output, is the path. So the path is something which uh, whenever you create uh, put a command, it actually goes to this path from left to right and try to see if you have that application available, right? So if I want to do say SFTP, or I want to do any SCP, and I'm going to say which SCP, you can see -user -bin. So if I want to do SCP, say I say SCP source and to target, that application will switch and come back to the path and try to see if I have user -bin somewhere here. Once it find user hyphen bin underneath, if I have the application directory, that means I can run that application safely. So, and you will see later on we'll create some script, and you will see that script is uh, path is not mentioned, so you cannot run it. And I'll show you how to run it if it is not mentioned in the path. I'll show you that as well. So this is probably the most important thing you should see. What is your path environment look like? All right. And since we are talking about the bash shell, uh, two important things or two important file you should pay attention to, because bash uses that heavily. The first is cat.profile. This is a hidden file. So bash uses this, as you can see, if running bash, and bash version is, so this is kind of like a quick script, then set the path like this. So this is how it actually created the path. And dot profile is read only once when you logged in. So it's not read with every command you fire. It just during the boot, it has been read once, and hence the path is set. The another one very interesting is bash rc dot bash rc, and here you can see I should have given some gap in between. So let me do a couple of this and then say cat. Hmm. You can see it's a long file, like 117 lines, right? This is the secret sauce, what's going behind. So we have the history, how much history we are going to store, and all those important system data is mentioned here in the bash rc file. Many a time uh, you really don't have to edit bash rc, but sometime when you install some custom program, that time probably you have to come and edit a few parameter here, but otherwise it's like you can leave it untouched. All right, so this is and also as we are talking about history, you can go back and say history hyphen how many commands you want to print, but let's say do. So all the commands what we have been using during this shell, you can see they are all available as part of history. And one interesting thing, if you want to repeat some command, say I want to go in a Python front shell, and during 252 I have given that command. So what I can do, I can use exclamation mark and 252. That will actually uh, re-enter the command. So you don't have to type the whole command. You can use just the number, how it was saved in history, and use that with exclamation mark, and you will be executing that command. Let me come out of Python shell, use quit, and that's how you come out. All right. Now what we will do, we will talk about something called htop or top. So let me clear this. So to know more about how your system is doing, right? In Windows, you have um, Windows Task Manager. Similar to that, we can use top. And as you can see, it gives you real-time stats, what's going on with your system. So top is one. There is a better formatted version of that is same application, htop. htop. Oh, htop is not installed, so it doesn't come by default. What you can do, you can use package managers like apt or snap to install htop. So we'll not go into that. Let's stick to top and see what we get from this top. All right. So the top will show you CPU, memory, and processes. So CPU, as you can see, this is um my system process, ideal process, and all those things about the CPU. Memory, two type of memory, the main memory and the swap memory. So almost 7 gig of main memory. Out of that, 4 gig is free and 544 is in use. 2 gig is in cache. And then we have a different set of memory which is used for running application called swap memory, 2 GB dedicated for that, but we are not using much swap because we have enough physical memory available. Swap is kind of like leverage when your system is running heavily on memory utilization. All right. So we have how many tasks running? 237 tasks running, and 236 are sleeping out of that. So you can see, obviously it's a multi-threaded process, so it picks up one task for the runtime and then release that and pick up another one. You should look at the load average. If load average goes 60, 70, 80%, it's something you need to address. And you can also see how many number of stop processes. Stop processes are not good for systems. Processes get systems switches from one process to another process, but if you see a lot of stop processes, you need to pay attention. Sleeping processes are fine. Zombie processes are something like if the program exit abruptly or error occurs, but the process lingers, right? So it's like not a clean exit. That time you will see the zombie processes. If you are seeing too many zombie processes, you need to pay attention and root cause that. All right. Here, so this is about the top, and then you can see the different columns. The first thing is you can see the PID. This is a process ID, and you can see there are process ID starting from 1 all the way to 10,000 or so. It goes very high number. Uh, so there are PID for processes. Who is the user who started this process? As you can see, I have probably mDNS running. That's why I all of a sudden saw Avahi, and but SDN2, this is the home user, and then we have a lot of processes running using root. Then we have um, nice value and process value, and we will talk about nice value. Nice value is a kind of if you want to give your processes QoS or quality of service, in lack of better terms, if you want to provide a better treatment, you can assign a nice value. Okay, and higher the nice value, lower is the privilege. So you can see -20, it ranges from -20 all the way to 20. -20 being lowest nice value, highest privilege. That's why with many root processes, you are seeing nice value of -20, right? Yeah, because we want to give them highest privileges. And then these are the CPU and memory being used for those by those processes. These you can see. And then we have S is what is a state. So what kind of state it is? You have running state, you have a sleeping state, you have stop state and zombie state, all those things. So you can have uh, S, which is stop, sleeping. You can see we have a lot of sleeping here. We don't have Z as a zombie, and we have one R which is running. Okay, so these are things you can know with your process. Let me exit out of this and also um, say we want to see a process. Okay, so what you can do, you can use PS, which is for processes, and every time you do PS, it uh, give you at least two, uh, uh, at least one, because the one is you just said PS, and that's what is going to. It's like an echo. It's going to reflect that here. Okay, sorry about that. But with PS, there are many flags. PS help, PS option. So these are the flags with PX. Most of the time, you would like to do AUX, and this is all the processes running on your system, right? So that's what you can do with PS. By default, when you do PS, it actually tells you with the whatever process is running with the current user. But if you want to do full result, then you have to do. So here you can see we have with all the users. So you can be creative with this. Finally, we are going to talk about a last thing here. I think today this video length is getting longer, so we will cut back on file permissions. We'll be touching on that next class. Quickly, last thing I want to show you is the shutdown. So you can have shutdown, and shutdown will obviously require the sudo privileges. So you can do shutdown. There are these flags available. So it says shutdown hyphen H. That means it kind of like a freezes all the processes and shut down the machine. You can do shutdown hyphen P, which is a power off. You can do R, which is reboot. So it will power off and then power up again, right? And this is shutdown hyphen H. It's and another interesting thing is hyphen C, which is uh, cancel. So if you can schedule a shutdown, and then you can go ahead and cancel it. So let me schedule a shutdown. I'm going to say sudo shutdown plus 10. That is a minute, 10 minute, and shutdown scheduled for this time. What you can do, you can say sudo shut down and hyphen C. So it's cancelled. That means there won't be any shutdown in the next 10 minutes. Right. So this is all I wanted to show you for this day 3 class. Day 4, we will move into file permission and start doing more things with the system. So I'll see you in the next class. I hope you're enjoying the series. Do like, subscribe, share, uh, tell your friends, colleague, and I'll see you in the next video.